Today we're going to talk about and we're also going to talk about point slope form. Now normally I would tell you, actually when you get out of this class, I won't have you again, but like I told the juniors last year and I told the pre-AP geometry students I have this year, I'm not a big fan of point slope form. Point slope form is pretty useless and redundant, and the way we use point slope form, we can avoid it by using slope intercept form. Alright, so the first thing we're going to do is we're going to we're going to skip all that. Sorry. We're going to write an equation. Let me give you the step. This is steps for writing an equation. Given a point. And a slope. So the first thing you do is you're going to start with your point slope form. And it's really logical if you think about it, because we're given a point and we're given a slope, so why not? Why would we not use point slope form, right? You're given a point and a slope, use point slope form.
Is that y minus 1?
It says y minus y1 equals m times x minus x1. So you're going to start with that. Always write that equation out, or that form out, so that way you have it and it helps commit it to memory. Once I've written that down, then plug in. So then plug your point into x1 and y1. Then plug your slope into m. So you're going to start with your point slope form. The y minus y1 equals m times x minus x1. Then you're going to plug in the point into x1 and y1. So you're going to plug in these right here. And then you'll plug your slope into m. So these three things are going to be replaced in your point slope formula once you start to use it. And then if necessary, our last step, solve for y if necessary. What does solving for y do? If I take this equation and imagine there's numbers in here, what does solving for y do? I'm sorry? Yeah, it puts it in the slope-intercept form. That's exactly right. Okay? If you solve for y, it's necessary so that you're in slope-intercept form. And again, if you haven't figured it out, you might be thinking to yourself, well, why would I go through that hassle just to go into slope-intercept form, which is what I already know? Well, I agree with you to some extent, but what Algebra 1 asks us to do is use this form because we can't go straight into slope-intercept form with the point and a slope. You have to have some kind of go-between. And so somebody created the point-slope form, which is fine, and I teach it, but I never use it. Okay? So you need that point-slope form in order to take that point and that slope, plug it in so that we can go straight to slope-intercept form. Yes?
Would you, if you're like solving for y, would you plug x into 0?
No. Not unless you were solving for the y-intercept. You don't do a whole lot with this form outside of plugging in what it gives you and then solving for it. Like I said, this form is kind of pointless.
Oh, okay.
So let's go through some examples. Okay, so example number 1. We're going to write an equation in point-slope form if I'm given the point -2, 6 and a slope of m equals -5. Okay, so I'm going to start with my point-slope form, which is y minus y1 equals m times x minus x1. One of the things I like to do whenever I'm trying to plug in anything that has a y1 and an x1, I like to go ahead and label my points. So I'm going to label this x1. I'm going to label this y1. That way I just know where to plug that in. Okay, you have to be careful. Don't plug it into the y and the x because that'll mess your whole equation up. Okay, because essentially what I'm doing is I'm taking the opposite of y1 and the opposite of x1 because of the negative sign in front. Okay, so when I plug this in, I'm actually going to have y minus 6 equals -5 times x minus -2.
Can we just change up the plus?
You can. I show you guys now because I'm trying to show you every step. But those of you guys, and I don't know what middle school taught this or whatever, but those of you guys who keep all the double signage, that's got to go. You cannot keep double signage. So immediately, if you do every single step like I'm showing you here, rewrite this problem as y minus 6 equals -5 times x plus 2. Do not keep double signage. It's only going to mess you up when the problems get longer. Okay? So that's point-slope form right here. So the first part of this question is answer this in point-slope form. There it is. That's point-slope form. Okay, the next part. We're going to take what we just created and we're going to turn it into slope-intercept form. And the reason is it's slope-intercept form that we use to graph more than anything else. We use slope-intercept form to graph. You can graph from point-slope form, but it's just not normal. Okay. Again, once you figure out the workaround, most people don't use point-slope very often. But you need to know it for your testing, and you just need to know it in general. What's the first thing I need to do when I'm solving for my x? For y.
Distribution.
Yeah. I need to distribute. That's why we did distribution first. Now I'm going to distribute what? I'm going to subtract -5 to these two numbers, right? Draw those arrows so you know. So -5 times x is -5x. -5 times 2 is -10. I want to continue to solve for y. What do I do now?
Add 6 to both sides.
I add 6 to both sides. That's going to cancel that there, giving me y equals negative 5x minus 4. And that's my answer. Any questions on that one? Okay, let's look at another example. We're going to write an equation in point slope form for a line that passes through negative 6 and negative 9 and has a slope of 1/3. Again, I'm going to go ahead and write my equation. Y minus y1 equals m times x minus x1. Having that, I'm going to label my point x1, y1. Mariah, what's my next line going to be on my solving process? What am I going to write next? Okay, what do I write next, Agracia? Y minus negative 6 equals 1/3 times x minus.
Wait, what?
It
No,
would be negative 9. It would be minus negative 9.
Okay, so somebody said it's backwards, meaning that, what do I need to do then?
Switch.
So this needs to become 9, and then this needs to become 6. You see where you went wrong there? Okay, not a big deal, easy fix. Okay, what do I do now, Mariah? Not yet. Caitlin, what do I do next? Okay, almost, but you skipped a part that you could have done. Why did you change x? Why did you change x minus minus 6? Why did you change that to x plus 6?
To take out the double.
So why didn't I do that at the beginning?
Yeah, I was just about to correct.
Okay. So go ahead, tell me.
Y plus 9 equals 1/3 times x plus 6.
Okay, good. I want to get rid of my double signage. So there is my answer in point slope form. Okay, example 3. 4, excuse me.
Is that all we have to do in our homework? We don't have to solve it?
Okay, example 4. Let's take what we just did and solve for y.
Okay, let's do it.
Okay, well you're asking, I mean, did we not solve for y a second ago?
Yeah, but on example 3. Okay.
Are we not about to solve for y right here?
I didn't know, that's why I was asking.
Be patient. Okay, what's the first thing I need to do here? Distribute the 1/3, right? Somebody yesterday asked me a good question. She said, do I multiply by 1/3 or do I divide by 3? Well, you can do either one. Okay, you can do either one. Multiplying by 1/3 is the same thing as dividing by 3. So I'm going to show you both. if I multiply by 1/3, I get y plus 9 equals 1/3 x plus 6/3. Okay, which we'll reduce here in a minute. Okay?
Wait,
When you multiply by a fraction, you just multiply the top number. Obviously, 1/3 times x is just 1/3. 1/3 times 1 is 1/3.
no.
1 times 6 is 6. 3 times, there should be an understood 1 underneath that 6. So 3 times 1 is 3. That's how you get 6/3.
No, we're talking about the other side.
We didn't do anything to the other side yet.
Oh, I thought you were.
Yeah, we have not done anything to the y plus 9 yet. Okay, on the other side, if I divided everything by 3, I get y plus 9 equals x divided by 3 plus 2. Okay, because 6 divided by 3 is 2. So if I come back over here, I get y plus 9 equals 1/3 x. I'm going to go ahead and reduce now, plus 2. You can see here that plus 2 comes out to be the same. Right? What do we know is in front of the x value when you just have an x standing by itself, like this? What's in front of that x value?
1.
A 1. So we know there's a 1 there. So is 1 over x the same thing as 1/3 x? Yeah. So this is the same thing as this. Okay? And this one you divide it by 3. This one you multiply by 1/3. Now dividing by 3 only works if the numerator is a 1. Okay? Yes.
So do you multiply it by the numerator and then you just keep the same denominator?
Well, yes and no. You multiply by the numerator. If this was a fraction, then you'd also multiply by the denominator. Because essentially, when you do 1/3 times 6, what you're really doing is 1/3 times 6 over 1. Because 6 over 1 is 6, right? So 1 times 6 is 6. 3 times 1 is 3. 6 over 3 is 2, right? So that's essentially what you're doing. So if this was like 6/5, then it would be 6/15. Okay. Okay. Now both of these are the same. So we're good here. So what do I do next to continue solving for y?
Subtract 9.
Subtract 9 from both sides. That gives me y equals. Notice how I only subtract from common terms, like terms. I don't subtract 9 from here because this doesn't have an x. I'm just subtracting 9 from the other naked number. So 2 minus 9 is -7. So there I've solved my answer. So I went from point slope here to y-intercept there. Or slope-intercept form there. Any questions? Okay. Let's do a little bit of a different example. So example 5. We're going to identify the slope and the point used to write the equation. So if I'm given y minus 3 equals 4 times x plus 2, I want to find the point. And I want to find the slope. Okay? Preston, what's the slope? That's the easiest one to find. What's the slope? You're looking at point slope form. What's the slope? Four. Yeah. The slope is 4. Okay? If we're looking at the point, tell me the x value of the point.
2.
No.
Nope.
Oh, why not?
Okay. What's the x value of the point, Savannah?
3.
Nope. What's the x value of the point? That's what we're looking for. Braylee, what's the x value of the point? It's not 2, it's not 3.
Oh, can I tell you again?
I don't know.
Is it, 8?
No.
Dang it.
8's not even up here.
Okay, but don't you have to distribute? Oh, no, that's after. Never mind.
I just want the x value. So one number.
I don't know.
Candace, what's the x value? It's not 2.
It's the X. 1. 4.
Oh my gosh. Oh, think about it. Think about the
Caitlin,
equation.
It's negative.
not negative
Think
3.
about the equation. It's
JD.
X minus 2.
Negative 2.
Oh,
Okay, look. Just like Nathan was saying.
Okay, I see.
This is y minus y1 equals m times x minus x1. So, in order for this to be a positive,
it has to be a negative number.
the other number has to be negative. So our x value then is negative 2. Mariah, what's our y value?
Negative 3. Or positive 3.
Positive 3. Remember, this negative value goes with the form. Okay? If it's not negative, it's the opposite. All you have to do is think about it this way. It's the opposite of this number here. So my y value is the opposite of negative 3, which is positive 3. My y value is, or my x value is the opposite of this number here. Opposite of positive 2 is negative 2.
So it's always going to be opposite.
Yeah, why are we packing up?
42.
I don't care. Okay?
Did I just turn a second, right?
Yes.
Huh?
I would like a shift.
Okay. Now, and Nathan talked about this a second ago. If I wanted to find the x-intercept, what would I do? Plug in 0 for y. So 0 minus 3 equals 4 times x plus 2. This would be for your x-intercept. We're not going to do it because of time, but this is for your x-intercept. What if I wanted to find the y-intercept? So plug in 0 for x. So 4 times 0 plus 2. That would be for your y-intercept, and then you would just solve. Okay, any questions?